Okay, so it says chapter 4, but this was for my honors algebra 2 class. Here's the quadratic formula. We talked about it briefly when we were trying to find zeros. So to get this formula, it's just completing the square if you use A, B, and C. So if you get rid of C, divide everything by A, take your B, divide it by 2, and square it and solve, literally that's where the quadratic formula comes from. Somebody was just intelligent enough to realize that and just did it. So if I'm given 2x squared plus 5x minus 3, 2 is my A, 5 is my B, and 3 is my C. And I could factor this, but maybe I couldn't, or I'm not sure. As long as it's a quadratic, raise the second power, and you can only do this, raise the second power. I have students that try to do it on a test with like x to the 4th. You can't do that. You'll be able to find your zeros this way. You'll be able to find, if I were to graph this, where it would cross on the xy axis. So you go ahead, and this is your opposite of b squared minus 4ac all over 2a. When you clean it up, it's going to be plus 24, so you get 49 over 4. So you're going to get negative 5 plus the square root of 49, negative 5 minus the square root of 49 over 4. Well, the square root of 49 is 7. So that's what gives you your two intercepts. You have to separate the plus and the minus. This will become 2/4 and negative 12 over 4. So this, if you graph that U-shaped curve, is going to cross the x-axis at negative 3 and 1/2. When your answers are nice and pretty like this, it tells me this could have actually been factored. That's fine if you didn't. So I want to talk today about complex numbers when we get solutions that don't exist. So these three, I want you to pause this video and I want you to try to find the solutions for 1, 2, and 3, because you need some practice with the quadratic formula as well. So pause the video, complete the quadratic formula, and then come back to it. Okay, when you've put A, B, and C in, and you clean it up, you're going to get negative 4 plus or minus the square root of 8 over 4. When you clean this up, it's 2 root 2. So how did I do that? The square root of 8, if you remember, is actually the square root of 2 times 2 times 2. When you have a pair, you remove it because it's actually saying what's the square root of 2 times the square root of 2, which is just 2. When I separate the numbers, I'm going to get negative 4 over 4 and 2 over 4. So I'm going to get negative 1 plus or minus square root of 2 over 2. So I have one answer, and then I have another. So I have two real answers. They're not going to be pretty like these, but they're going to be decimals, and that's fine. We're just rounding. Here, I brought 4 to the other side. I noticed that I can trim some fat here. I have a 2 that can go into everything. So this is my quadratic formula. If you used these numbers, you're going to get the same answer as if you use this number, or I'm sorry, these numbers. So opposite of b plus or minus b squared minus 4ac all over 2a, or a is 1. It's going to be 0. You're going to get negative 2 over 2 plus 0. So it's negative 1 plus 0, negative 1 minus 0. It's the same answer. So you're going to get one answer. So what it would look like graphically, it's just at negative 1. It just touches. It's tangent. It's called the double root, and that's what ends up happening. So I have 2 answers. I have one answer. And then when I simplify this guy, I get the square root of negative 8. If you put that in calculator, you don't have a real answer. No solution. What's that look like? I don't know where it's at, but what it's doing is it's hovering over the x-axis. You're never going to intersect or touch. So you have it going through 2 points, at 1 point, and no points. And what were the differences of all three? Well, I had a square root of a negative, I had a square root of 0, and I had a square root of a positive. So when you have a square root of a positive, 2 answers. When you have a square root of 0, 1 answer. And when you have a square root of a negative, 2 answers. Now this chunk underneath the square root, the b squared minus 4ac part, is called the discriminant. Okay. So when b squared minus 4ac is greater than 0, when it was that positive number, you had 2 solutions. When it was b squared minus 4ac is less than 0, we didn't have a solution. It was -8. When it's b squared minus 4ac equals 0, we had one solution, the -1. Okay, we went through these questions together. So it says, even when the discriminant is negative, though, like that -8, there's still two solutions. They're just not real. Okay, there's a number system called the complex number system. So just because it isn't in the real number system doesn't mean that it doesn't exist in another. So complex numbers, that includes real numbers and non-real numbers or imaginary numbers. The imaginary unit is called I. So if we ever see a -1, square root of it, we're just going to call that I. So you can remove the negative. So it's I root R if you have a negative. So here, this is the same thing as -1 and 9. Well, we know what the square root of 9 is. It's 3. And we know what the square root of -1 is. It's 1. So we call it, or I'm sorry, I. So we call it 3I. Or you could just say, yank the negative out and call it I. Well, the square root of 16 is 4. 4I. Now, this is considered theoretical math. And the cool thing about math is a lot of times theoretical math can eventually become applicable math. And if you're going to be an electrician or doing something where you need to find solutions, more technical things, I's actually do come into play. Then we break the 40 down. We know 40 is going to be 2, 2, and then 10, 2, 5. So 2I root 10. Okay. So you could go again and try this. So let's see. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So it's going to be -3 plus or minus, well, what's -24 plus 9? That's going to be -15 all over 12. I'm going to make this 3 over 12 plus or minus, yank that negative out, I root 15 over 12. So this is 1/4 plus or minus, well, 15 can't be broken down anymore. And you can't simplify this way because this is under a root and this isn't. So this would be your answer. Not pretty, I know, but that's actually your solution. Okay. Down here, it says a complex number is any number written as a plus bi, where a is the real part and b is the imaginary part. Okay. So in the form a plus bi is called standard form of a complex number. Real numbers are complex for which b is 0. So if there's no I part, that's fine. It's a real number. If there is just an I part and no other part, then it's just a pure imaginary number. So 5's a real number, 2I is a pure imaginary. If I had something like 6 plus 3I, it's complex. It's just not as pure as the 2I, and it's just not real. Here, they're saying find x and given y. So if they're telling you that these two things are equal, put the real parts with the real and the imaginary with the imaginary. So 3x equals 21, and then the 4iy is equivalent to the -16i. X is -7. Divide both sides by 4i, and y would be -4. Okay, you can do the same thing over there. All right. So operations, if I have I, that's the square root of -1. Okay. If I have I squared, that's the square root of -1 times the square root of -1, which is just -1. And you're like, huh? Well, if I had the square root of 3 times the square root of 3, your answer is just 3, because that's the square root of 9. So if I have the square root of a times the square root of a, my answer is a. So if I see an I squared, it becomes real. And this is what's cool about I's. It goes in and out of being real and non-real. If I have I cubed, I know it's I squared times I. Well, I know I squared is -1, and I is I, so it's just -I. And then I to the 4th is I squared times I squared. Well, we know I squared is -1, and I squared is -1. So I to the 4th is 1. So it's really interesting. It's cyclical. It's in these cycles of 4. If you go to I to the 5th, you know it's I to the 4th times I. Well, I to the 4th is just 1 and I is I. So we go back, I, -1, negative I, 1. So this is going to be -1. This is going to be negative I. This is going to be 1. And it's cyclical. Okay? You just need to really remember I squared is -1 and I to the 4th is 1. Okay? Here, it's just combining like terms. If you want to pause the video and try it, go ahead. I think that would be beneficial so that when you see when I'm doing this, it makes a little more sense. Having that background knowledge of trying each one rather than watching me. So pause for a second and try it. We're going to have a -10 and a 8, which is -2, and a -7i. That's it. They just wanted you to simplify. They just wanted you to combine like terms, and you're very capable of that. When I distribute the negative to both, be very careful. You're going to get a 6i. When I add these two quantities, everything's going to cancel. Here, I'm foiling. I'd write 10 minus 5i, but you get the point. Here's the thing. When you have an I times an I, that's I squared. That I squared is technically -1. So it's a negative, which becomes a positive. Be very careful. Don't leave it as I squared. Here it's going to end up being the same thing. -4 is a positive 16i squared. That I squared is going to be negative. So really it's 30 minus 16 minus 44i. This is actually going to be 24 minus 44i. All right, and last one here. I is in the denominator. Technically, I is a square root. If you go back to your Algebra 1 days and you had an answer like this, you could not leave it. Mostly because it's just a faux pas. Like, you can't divide by something that never ends. So mathematicians all came together with a consensus and said, that's improper. It's like leaving an answer as like 2/4. You need to reduce it. You need to rationalize it. This is technically an irrational denominator. Let's make it rational. So I'm just going to multiply it by the square root of 5. When I do that, I'm going to get 5. It's going to be all pretty. However, I can't just multiply something by 1 over the square root of 5. I'm changing its actual value. If I multiply the top and bottom by the same thing, I'm not changing the value. I could put this in the calculator, get a decimal, and put this in the calculator and get a decimal, and they're the same thing. I'm just essentially giving it a makeover. Because the square root of 5 divided by the square root of 5 is just 1. So this is your answer. Okay? So here, we're going to multiply what's called the conjugate. If it's a plus bi, I'm going to multiply by a minus bi. Because if I just multiply by I, it'll transfer over to the 2 and it won't work. You can try it. So I need to multiply the top and bottom by the same thing, which is its conjugate, 2 minus I. If it was a minus, I'd use a plus. So when I FOIL, 2 times 2 is 4, 2i minus 2i minus I squared. Then I'm going to get 8 minus 4i plus 4i minus 2i squared. You might have an I in the numerator, and that's fine. We just don't want one in the denominator because it's not rational. So I cleaned up the numerator, cleaned up the denominator. We realize an I squared is actually a -1, so it's going to be negative, so it's going to be 4 plus 1. That's going to be a -1, so it's going to be 8 plus 2. And we're going to get 10. We're going back to the real number system. We end up with 2. Okay? I'd multiply the top and bottom by a -2 minus I. I'd multiply the top and the bottom by a -4 plus 5i. Okay, so you can practice on that. That's in your homework. All right? So on this next page, these are the notes I give to my high school students, but I think they're beneficial. It says, what is a discriminant? The discriminant is it's b squared minus 4ac. It's whatever's under the radical. The discriminant determines what kind of solutions you're going to have. 2 solutions, no solutions, 1 solution. Okay, it says use a discriminant to determine how many types this is going to have. So if I just look at the b squared minus 4ac part, I'm going to get 9 minus 16, which is negative 5. I will have two complex solutions. Okay. Now, let me show you real quick how it actually works. So if you have an equation that's x squared plus 4 equals 0. What does x have to be to make this true? If you were to graph it, you could see that you're x squared, but you're up 4 because it's the plus 4. 1, 2, 3, 4. So you never cross the x-axis. You're not going to have a solution. But that's in the real number systems. So if I go to solve, and I take the square root of both sides, the square root is always the positive and negative solution because we're solving. Well, I see a negative, yoink. And then if I take the square root of 4, I get 2. So my solutions are 2i and negative 2i. If I substitute them back in, they're going to work. So it's kind of like, not like a placeholder, but it's a filler. It's something to be able to solve the equation. It's applicable. So if I substitute in 2i squared plus 4 equals 0, I'm going to get 4, and then I'm going to get I squared plus 4. And then we know I squared is actually negative 1. And I'm going to get negative 4 plus 4, which is 0. That's it.